This is CS50's Introduction to Game Development. This is the Match 3 assignment number 4. It pretty much plays like Bejeweled or Candy Crush or anything like that. So if you match 3 tiles in a row, it results in a match. The tiles are removed, new tiles are generated. We introduced the notion of having a flashy tile. So if your flashy tile is part of a match, then the whole column or the whole row is removed as a result of that. Another feature was increasing the timer by 1 second for every tile as part of a match. So I'm going to match this whole vertical column here. There's 8 tiles in that match because we're going to have a flashy column here. And you can see the timer increased by 8. If we have a match here, it only increases by 3 because there are only 3 tiles as part of that match. Another requirement was to have basic colors on level 1, then level 2 onwards we increased the complexity. So we can see that in a second. Once we get to level 2, there we go. So you can see level 2 here is a lot more complex. Another feature I added was having the ability to show the user how many matches there are left to find. These are possible match combinations. So it started out as a debugging thing, then I thought it was a pretty cool game feature, so I implemented that as well. Another one was the optional usage of the mouse. You can see I'm using the mouse right now. That was quite nice flow. If you leave the board area, it remembers the last one, you can kind of continue. You can also interrupt the mouse and use the keyboard, and then carry on with the mouse. So I thought that was quite nice to have seamless mouse and keyboard gameplay, so you can kind of change from one to the other mid-game. With the mouse you just click the button to change the tiles, and the keyboard works as before with the enter key. So another thing, you can't move a block where there's not a possible match. It simply doesn't let you. It'll only let you move it if there's a possible match ahead. And again, with this hint feature here, it checks the whole board to see if there's possible matches. So let's take a look at the code and see how it was all implemented. So let's delve into the code and look at how we kind of tackled those requirements there, or at least my interpretation of them. So the first requirement is to implement the time addition, so that when you get a match, you get a 1 second increment per tile in the match. So we already have code for calculating the matches, which returns the number of tiles in the match, and it's already incrementing the score multiplied by 50, so pretty much just added this line here which increments the current timer belonging to the play state by just the number of tiles in the match. So that one was relatively straightforward. The next requirement was ensure level 1 just starts with simple flat blocks, which is the first of each color in the sprite sheet. And then level 2 and onwards, what I did was just generate everything as before. So it's just level 1 is like a baby step, and then we kind of carry on. This is the sprite sheet, so it's pretty much just these lines right here, which is the first index of each color of 6 blocks. So for this begin place game state here, I moved the code for the board constructor from the init function down into the enter function. This allowed me to pass the current level into the board constructor here. And I'll cover this code a little later on that. Board line 40 is where we start looking at the level there. So in initialize tiles, we're saying if the current level is 1, then set the variety flag, which is a variable I created, which just indexes a variety of tile. So the variety flag here would be 1, 2, 3, 4, etc. That's pretty much how it works. So on level 2 and onwards, we're just generating a random tile between 1 and 6 because we don't care about basic blocks there. And we're passing that into the constructor of the tile right here. So if we go to line 382 or thereabouts, when we get a match, we need to generate new tiles. So on level 1, our variety flag will already be set at 1, but if we're on level 2 onwards, we're just saying if the level is not equal to 1, generate a new random tile variety between 1 and 6 and pass that into the tile constructor. So that's how we generate different varieties of tiles there. for that requirement. So level 1 will have those flat blocks. The third requirement is generate random shiny versions of blocks that would destroy an entire row. I interpreted this as column as well. So in our tile lure, we're passing in a shiny tile flag here. We have a shiny block helper that I've created called toggle. And we're setting up a new timer, so every quarter of a second we're just setting the toggle from true to false to true to false. When we actually render the tile itself, we're just saying, is the tile a shiny tile? And if we're on, say, a true state of the toggle, then just literally toggle the opacity of the tile, and it gives it that kind of nice blinking, flashing state, which is pretty cool. If I go to line 22, this is a constant variable I created, a shiny block chance. So I'm doing a 1 in 15 chance here. If we go down to here, right here, so there's a 1 in X chance it's a shiny tile, so it's just a random number between 1 and 15, and we're saying, oh, if that's equal to 1, then this is a shiny tile, and that's how that feeds into the kind of tile lure file there. And I'm also adding this, which I'll kind of cover in the last requirement a little as well, is only the possible colors that I want in the game. So there's like 3 shades of red, 3 shades of pink. So I'm just kind of handpicking those out and putting them into a table. And I'm also feeding that into the tile constructor here. So we're pretty much passing in an index from our table here. So they're the only colors I want in the game. So there are a few of the changes I made for that. And how we implement that, so when we're dealing with a shiny tile, so this is where we calculate matches for the board. If we know we have a match of 3 or more tiles, so 3, 4, 5, all the way to 8 tiles in a row, then we know we have a match, and we're literally just adding all the tiles in our match to our table as before. But what I did, I'm saying if any one of these tiles is a shiny tile, then just set up a new for loop for the whole horizontal row and add everything in that row to the table. Break out of the loop because we've already added the whole row. There's no sense in repeating all this logic. And now add the whole row into our kind of table of matches. The table of matches here gets returned and purged by existing code, so I felt for this requirement, if I just add it here, I don't need to change anything else elsewhere. So I did that for each horizontal row, the last row, each vertical row, and the last one. So that's how I kind of implemented removing the whole row and column for that. And again, with that, the score will, and the timer will increment perfectly as well. So the next requirement was allow swapping only when it results in a match. So before you can move a tile all the way across the board, now you can only move it if it results in a match. So for here I added a function, a couple of them actually, but it ties in with the next kind of sub-requirement of this, which is resetting the board if there are no possible matches left. So let's cover all of that. If I go to line 286 on the board, so I reused some existing logic here, but I've just brought it into a function called switch tiles, and what that will do, it will take a tile 1 and a tile 2 and switch them around. So the code behind, all the code behind for that, so it's just reusing existing code, but really just pulling that out, so I don't need to keep writing all this. Play state 221. Okay, so this is existing logic here for, let's go up. So yeah, the update function. So this is where I'm actually switching the tiles themselves, the actual switch of that. So I'm getting the new tile, so that's our kind of target tile. I'm calling self.board.switch tiles, so that's the function I just talked about there, so that's where I moved that code to. And we're moving the highlight tile into the new tile position. Now I'm reusing calculate matches to see if we have a match. If I don't have a match, then I just want to switch them back, so I'm just reversing the parameters here, and then I'm playing the error sound like here. I'm just kind of reusing that. However, if the match is good, then just do the timer kind of tween stuff as before. If I go to board, line 230, I added a new function here called has matches, and what that does, it goes through the whole board from left to right and replaces each tile all the way across, and again all the way down as well to check for vertical matches. So that's all this function does, and that gives us an opportunity to work out if we have any matches left on the board. But also, when we generate the board for the first time, we don't want to generate a board with no matches, so I kind of used that as well. So for this, I just literally have a nested loop. On the x-axis I go up to 7 because I don't want to kind of go over the edge of the board. We're just saying, look, is there a match? If so, increase a match count by 1. So what I'm doing here, I'm returning the number of matches, and I find that that helps me with my cool little hint feature that I added in the bottom left corner. And again, I could use a table here, and that gives me an opportunity to visually hint out where matches are if the user is kind of stuck. So it can be implemented even more, but it was just a design choice to return an integer of the number of matches that I found here. It started as a debugging tool, but then I thought it'd be a cool hint feature. So that's has matches, and in begin game state line 35. So what I'm doing, I'm generating the board for the very first time, and if there's no actual matches, then just regenerate the board again. So that's kind of where I reused that code there. And in play state line 93. Okay, so when I'm updating here, I'm saying I'm setting a variable called available match count to the result of has matches. If there's no matches on the board itself, then generate a whole new board here, just like before. Pass in the current level because we don't want to increment the level. Do some visual cool stuff, and just display a message to the user and say, oh, there's no more matches, here's a new board for you. I think that is right here, yes. So so just say no more matches Y. It just says no more matches and comes in the screen and disappears, and that just keeps track of the y-axis, kind of like the new level thing. This is the hinter stuff I added. It just says if there's one available match left, so this is the result of that function called has matches. If there's one match, it just says there is one match left to find. If there's more than one, there are X matches to find. Board 25. Yes, and we talked about the possible colors as well, which was just having 8 kind of possible colors in the game, and because when you're checking all that logic, it just helps have a few less colors in the game. Otherwise, you'll keep regenerating the board over and over until you don't have a match. So that was a nice kind of optimization as well. Okay, so we've covered that, the hinter, and also the last optional requirement was to implement matching using the mouse. So I added the plumbing code in main, which was initialize the mouse input table, the functions here, so everything to do with that, and kind of reset it here on Love2D, so that allowed me to kind of start using the mouse. And then in play state line 150, this is the bulk of it. So if we can input, so the match is done, we can now allow the user to input. This is the function here, so I'm getting the mouse position, pushing that to push to get the mouse coordinates. Now I don't want anything to do with the mouse outside of the board itself. We really don't care about that. And I also want to get a mouse tile based on the coordinates of the mouse. So when we hover over a tile, using the mouse coordinates, we want to get the actual tile on the board. So this will be a number between 0 and 7 for each X and Y. And this is where it gets a little complicated because we can use the keyboard, but we can also use the mouse. I wanted the user to be able to switch mid-level, or well, whenever the user wanted to, so it is a little complicated. So this part here is checking that we're on a valid tile on the board, so that's from 0 to 7. Otherwise we'll be selecting squares outside the board, so that's what this kind of logic does here. I'm storing a variable locally called last mouse tile X and last mouse tile Y, and we're setting these every kind of iteration of this function and just storing them locally. So this pretty much tells you that the user has moved the mouse because the last coordinate of the mouse is different from last time. We're setting a local variable called input type to mouse. That's here. So this could be key for keyboard or mouse for mouse, and there are kind of last coordinates for that. So go back to 150. So if pretty much the user's moved the mouse and they've moved it on the board, set it to mouse, and then if the last highlighted tile is not equal to the current tile the mouse is over, then play the select sound. Because the last thing we want to do is play the select sound even when the mouse is on the current tile, otherwise you get a kind of long whining select sound, I imagine. So I just make sure the sound is played on a new kind of drag over the a new tile, if that makes sense. Then actually make the selection. So everything's valid, make the actual selection with the mouse, and that lets you do that. The thing I changed with the keyboard here was just say if the user presses up, down, left or right, change the input to key. So when we recall this, we're not going to do all this mouse logic because we're currently in keyboard mode. If that makes sense. Then on line 199 I just added this section here to here, so if instead of enter and return and we're using the keyboard, so all of that, or we're pressing the button on the mouse and our input type is mouse, then just do all the logic as before. So I believe that is everything I've done with this project. So yeah, that's the input. It was an optional feature, but I thought it added a lot of gameplay, and it's really nice moving the mouse to kind of change those tiles along. So yeah, I had quite a lot of fun with that actually. It was a nice little project. So thanks for watching, and if you're doing it, good luck with your assignment too. Take care.